Hi everyone, my name is Carolina Grando and I'm a postdoc researcher from the National University of San Cristóbal de Huamanga in Ayacucho, Peru. And I'm here to present my work, Reduction on Effectiveness of Amazon Protected Areas under Climate Change, Threatens Plant-Animal Interactions. As introduction, protected areas are an essential strategy to conserve biodiversity and ecosystem services throughout generations, and some authors consider that protected areas are acting as a buffer to species adaptation to climate change conditions. However, the accelerated pace of climate change due to human actions may reduce the long-term effectiveness of protected areas in safeguard species and their biotic interactions. So the objective of our work was to use ecological niche modeling to evaluate the long-term effectiveness of Amazon protected areas, focusing in plant and animal interaction, with emphasis on pollination and seed dispersal in the emergent tree Dipteryx micrantha. In the methods, we used 5 algorithms to forecast present and future habitat-suitable areas for Dipteryx micrantha and its interaction with 5 bee pollinators and 6 bed dispersers. And for the future scenario, we used an ensemble of 3 projections in the RCP 4.5 scenario from 2061 to 2080. And we estimated the intersected reduction, increase, or maintenance of the species distribution within the protected areas. For Dipteryx micrantha, we observed mainly a reduction of habitat suitability for the future scenario in protected areas. So we observed a split in the future scenario in 2 largest suitable areas, one in the north of Peru and another one more in the south of Peru, separated by several smaller disconnected ones. For the overlaying of Dipteryx micrantha with bee pollinators, we observed that the reduction of habitat suitability surpassed the increase in the maintenance for the future scenario in protected areas. So in the table 1, where is it possible to observe the number of protected areas with reduction, increase, or maintenance, the highest reduction was observed for the interaction of Dipteryx micrantha and Lemma moxari in 221 protected areas. For the overlaying of Dipteryx micrantha with the most of bat species, we also observed that the reduction of habitat suitability surpassed the increase in the maintenance for the future scenario in protected areas. So we observed the highest reductions for the overlaying of Dipteryx micrantha in Artibius obscurus and Artibius planirostris, both in 221 protected areas. But we observed an exception for the bat Artibius concolor, with an increase in 151 protected areas in the future scenario. And this increase was due to expansion of habitat suitability areas in the future scenario. In the conclusion, our results suggest a reduction of effectiveness of the most Amazon protected areas under a future climate change scenario, with disruptions in both biotic interactions like pollination and seed dispersal, and also in evolutionary process in the Amazon rainforest. Thank you for your attention.